In this video, we're going to talk about sum to product and product to sum formulas. So this is the last section of all of the different formulas that we've been learning in Chapter 7. So again, if you haven't already, please start studying those for Test 2, make flashcards, make a Quizlet, that might be a good idea. Write them when you do your homework. So every time you need to use a formula, write the formula out before you substitute in things, and so on. So just make sure that you're super familiar with those formulas because you do not get a formula sheet for the test. Okay, so the sum to product formulas are when we have something written as an addition or subtraction problem, but we want to turn it into multiplication or division. So first, maybe we have two signs added together. So maybe we have sine of x plus sine of y. And we're going to say that x and y are angles. Okay, so if we have sine x plus sine y, this is equal to 2 times the sine of x plus y over 2 times cosine of x minus y over 2. Okay, so that's if you have sine plus sine. Maybe we have sine minus sine. So if we have sine x minus sine of y, that's going to be equal to 2 times cosine of x plus y over 2 times sine of x minus y over 2. Okay, third, if we have cosine x plus cosine y, that's going to be equal to 2 times cosine of x plus y over 2 times cosine of x minus y over 2. If we have a difference of cosine, so if we have cosine x minus cosine y, that's going to be equal to negative 2 times sine of x plus y over 2 times sine of x minus y over 2. So those are our most basic for sum to product formulas. We also have a couple for tangent, so we'll write those down, but they're not as important. So fifth, if we have tan x plus tan y, that's equal to sine of x plus y over cosine x cosine y. And finally, if we have a difference of tangents, so if we have tan x minus tan y, that's going to be equal to sine of x minus y over cosine x cosine y. Okay, so those are our 6 sum to product formulas. So now let's practice using these with a couple of examples. So we're going to be given a sum in the following problems, and we want to rewrite the sum or difference as a product. So in example A, we have cosine of 6t plus cosine of 4t. So since this is a sum of cosines, I'm going to use formula 3. So I'm going to make a little note of that, so when you're going back and looking in your notes, you know which formula we used. So if I'm using formula 3, then that's going to be 2 times the cosine of the two angles added together divided by 2 times the cosine of the two angles subtracted divided by 2. So we've got 2 times the cosine of 6t plus 4t divided by 2 times the cosine of 6t minus 4t divided by 2. And now all that's left to do is we need to simplify the expressions in the parentheses. So we get cosine of 10t divided by 2 times cosine of 2t divided by 2. And finally, if we divide both fractions in those parentheses, we get 2 times the cosine of 5t times the cosine of t. So that is the simplest form of the sum now written as a product. Okay, let's try another example. So our next example, we have sine of h minus sine of 3h. So since this is sine minus sine, we're going to use formula 2. So that's the one where you have sine x minus sine y. And so the way that one goes is we're going to have 2 times the cosine of the two angles added divided by 2. So we have h plus 3h divided by 2. And then we're going to have multiplied by that, we're going to have sine of h minus 3h over 2. Okay, so now we just need to simplify the things in the parentheses. So we have 2 cosine of 4h over 2 times sine of negative 2h over 2. And if we keep simplifying, we just have 2 cosine of 2h times sine of negative h. So now here, this is almost simplified, but notice that we still have a negative sign inside of the sine function. So what we can do to simplify this a little further is we can just take that negative sign and move it out front, since sine is an odd function. So we can just say that this is negative 2 cosine of 2h sine of positive h. Okay, so that's the simplest form of example B. So let's try one more. Let's put in some numbers, but we're not going to actually evaluate this. We're just going to turn it into a product. Okay, so in this one I have sine of negative 1 degree plus sine of negative 2 degrees. So since I have a sine plus a sine, I'm going to use equation 1. So this is going to turn into 2 times the sine of negative 1 degree minus 2 degrees over 2 times the cosine of negative 1 degree minus negative 2 degrees divided by 2. Okay, so notice what I did here. So inside of the sine, that's where we had x plus y over 2, but since both x and y are negative, what happened was we got negative 1 minus 2. In the cosine function, that's supposed to be x minus y over 2, so we had negative 1 minus negative 2 over 2. So sometimes when you have those negative signs, it can get a little confusing, so make sure to pay attention to exactly what the formula says. All right, so we just need to simplify the expressions inside the parentheses. So to do that, we can do 2 times the sine of negative 1 minus 2 gives me negative 3. So I have negative 3 over 2 degrees times the cosine of negative 1 minus a negative 2 is plus 2. So we'll have 2 minus 1 is just 1. So 1/2 degree. Okay, so this is our sum written as a product, and it's not super useful because our degrees are fractions, which we don't always want. So that's why we're not going to evaluate this. But the idea is just we're starting with a sum or difference, we're turning it into a product. Okay, so what if we go the opposite way? So what if we start with a product and want to go to a sum? So once again, we have a few different formulas for this that we're just going to go through really quick. So first of all, if I have sine of x times sine of y, that's going to be equal to 1/2 times cosine of x minus y minus cosine of x plus y. If I have cosine x times cosine y, that's going to be equal to 1/2 times cosine of x minus y plus cosine of x plus y. And then third, if I have a mixed product, so if I have sine times cosine, so I have sine x times cosine y, or in the reverse order. So since multiplication, we can multiply things in any order. This would be the same formula as if you had like cosine of x times sine of y. So anyway, this formula is going to be 1/2 times sine of x plus y plus sine of x minus y. Okay, and then finally we have two formulas for the product of tangents that aren't as important, but we're going to write them down anyway. Sorry, that's number 4. Okay, so fourth, we could have tangent of x times tangent of y, and that's equal to tangent of x plus tangent of y divided by cotangent of x plus cotangent of y. And then finally, we could have, it's number 5, finally we could have tangent of x times cotangent of y. So that one would be tan x plus cotangent y divided by cotangent x plus tangent y. Okay, so those are our 5 product to sum formulas. So let's practice using those just like we did in the sum to product formulas. So in these, we're going to rewrite each product as a sum or difference, and we're going to evaluate if possible. So in these examples, I think you'll see why these are actually useful, because what happens sometimes is maybe we start with a product of things that are not on the unit circle, but then when we turn it into a sum, maybe the angles change to where we can actually evaluate them because those angles are on the unit circle. So we're going to see that happen in example B. But first, let's do A. So we have 20 times the cosine of 36t times the cosine of 6t. So since I have cosine times cosine, I'm going to use formula 2 from the product to sum box. So formula 2 says that the product of two cosines is equal to 1/2 times the cosine of the difference of the angles. So we're going to have 36t minus 6t plus cosine of the sum of the angles. So we're going to have 36t plus 6t. And then this one, since I have 20 out front of the product, I'm still going to keep the 20 out front of that product. So the formula is substituting the product of the two cosines, but the 20 is still going to be in the front of that. Okay, so this is my entire expression written using formula 2. So what I can do now is just simplify everything. So first of all, 20 times 1/2 gives me 10 on the outside of the bracket. And then if I simplify each of the sum and difference of the angles, we get cosine of 30t. So 36 minus 6 is 30. And then in the other angle, we get cosine of 36 plus 6, which is 42t. All right, and that's as simple as we can go, unless you want to distribute the 10, so we could do that. So we could say this is 10 times cosine of 30t plus 10 cosine of 42t. And then technically your answer is now wholly a sum. Before, we still had 10 multiplied by something, and that operation was outside of the adding. But now the adding is our main operation. So this answer is probably what WebAssign will like better. Okay, so now let's actually try to evaluate something in example B. So we have the sine of negative 345 times the sine of negative 15. So since I have the product of two sines, I'm going to use equation 1, which is sine x times sine y. And what this formula tells me to do is I'll have 1/2 times the cosine of the difference of the angles. So we'll have negative 345 degrees minus negative 15 degrees. And then I'm going to subtract from that the cosine of the sum of the angles. So when we sum the two negatives, we're going to get negative 345 degrees minus 15 degrees. So again, with those negative signs in the angles, just be very careful as to whether your formula is telling you to add or subtract. Okay, so now all we have to do is simplify the angles inside of those cosine functions. So we can say that this is 1/2 times the cosine of, so negative 345 plus 15 will give me negative 330. And we're going to subtract from that the cosine of negative 345 minus 15 is going to give me negative 360. So we have the cosine of negative 360 degrees as our second cosine. Okay, so now we have our angles in degrees, and you might recognize that those are actually angles on the unit circle. So just to get some practice, what I'm going to do now is just convert these to radians because that's how I think better. But if you think okay in degrees, that's fine. So negative 330 is the same as negative 11 pi over 6. And then negative 360 is the same as 2 pi. All right? And now we can go one step further. So when we're talking about negative 11 pi over 6, we're starting at 0, and we're counting backwards until we get to 1 pi over 6 before we hit 0 again. So this would be negative 11 pi over 6, but as you can see, that's the same thing as positive pi over 6. So what we can say is this is actually 1/2 times the cosine of pi over 6 minus the cosine of 2 pi. Okay? And so now these become pretty easy to evaluate. So cosine of pi over 6, well, we know that from the unit circle. That's just root 3 over 2. So we have 1/2 times root 3 over 2 minus, and the cosine of 2 pi is just positive 1. So we have root 3 over 2 minus 1. And so the last thing we can do is just distribute the 1/2 inside. So we have root 3 over 4 minus 1/2, and then we can just write that as a single fraction. So we have root 3 minus 2 over 4. So that 1/2 turns into a 2 over 4, and so that's how we get the 2/4 over here. Okay, so that's an example of something where the product to sum or the sum to product formulas actually help us evaluate something. But now we're going to talk about proving identities again, because I think that that's one of the harder concepts for people to get a hang of. Okay, so this first one, I put it in the notes without actually working it out. Turns out it's quite tricky, and so I think that it would not be very beneficial to go through it. So we're going to skip this one. However, if you would like a challenge and you really want to test how well you can prove identities, you're welcome to work that, but you can do that on your own time. We're going to move on to example B, because this one's a little bit shorter, a little more in our line of what we want to be doing. So our first identity we're going to prove is 2 times cosine cubed of x minus cosine x sine squared of x is equal to cosine of 3x plus cosine of x. So remember, when we prove identities, we always want to start with the more complicated side. But it turns out when you're doing these sum to product and product to sum formulas, sometimes it's easier to start with the side that maybe doesn't look more complicated, but maybe it's easier to expand out. So in this case, when I'm looking at the right side, I'm saying to myself, well, right away, I see that that's a sum of cosines. And I know that I'm doing a sum to product formula section, so I probably want to start with that side and see if I can expand it out using my equations. So even though it doesn't look as complicated, we're going to start with the right side. So we're going to start by copying down the right side, and then we're going to apply our sum to product formula. So since we have cosine plus cosine, the formula for that is going to be 2 times the cosine of the sum of the angles over 2 times the cosine of the difference of the angles over 2. Okay, so notice what I've written here. I have 2 times cosine of 3x plus x divided by 2 and cosine of 3x minus x divided by 2. So now what I need to do is just simplify the insides of those cosines. So we have 2 times cosine of 4x over 2 times cosine of x over 2, 2x over 2. All right, and if we keep simplifying, we get 2 times the cosine of 2x times the cosine of x. Okay, so let's at this point pause and see where we want to end up. So we have 2 times cosine of 2x times cosine of x. We want to get to this left side. So we have 2 times cosine cubed minus cosine times sine squared. So what I'm going to do up here is just make a little note to myself and factor out a cosine. So I notice that both terms have a cosine, so maybe that'll give me some indication of where I want to go down here if I work a little bit backwards up here. So if I factor out a cosine of x, maybe I'll do this in a different color so that you know it's not part of the problem. So I'll do this in red. Okay, so we have 2 cosine x, and then I'm left with cosine squared of x minus sine squared of x. Ooh, I like how that looks. Okay, so why do I like how this looks? So remember, cosine squared of x minus sine squared of x was actually an identity that we did way back, well, no, not way back, I guess in the previous section. So when we talked about double angle identities, this was an expression for cosine of 2x. And why is that good? Well, I've got cosine of 2x sitting in my problem down here. So that kind of tells me what I need to do next. So what I can do is in place of cosine of 2x, I can substitute in that identity. So I can say cosine of 2x is just cosine squared of x minus sine squared of x. And then I still have that factor of cosine x outside. And then all I need to do is distribute in that cosine of x, and I've got my right side or my left side of my identity. So we just have 2 times cosine cubed of x minus cosine x sine squared x. And now I have exactly what that left side said. Okay, so this is a good problem for when you get stuck on these. Think about where you want to go. So that's what we did. We went to our left side and we thought, okay, let's see if I can start to work backwards a little bit. And we said, okay, let's factor out cosine of x. And that was what showed us what we needed to do going forwards at the bottom. Okay, but note that the stuff that I wrote in red is not part of your solution. That's sort of like scratch work off to the side. But sometimes that's a handy way to do proofs, is maybe you start at the beginning and you work forwards a little bit, and then you start at the end and you work backwards and it meets in the middle. Okay, but notice that that doesn't mean that we're working both sides. So we still kept it as we started at one side and got to the other side, but working backwards sort of helped us see what to do next. Okay, that's very important to realize. Okay, let's try another one. So in this one, we have 2 times tangent of x times cosine of 3x is equal to secant of x times sine of 4x minus sine of 2x. So this one, I think it's a little easier to start with the right side again. So this time we're actually going to start with the side that looks more complicated. So I'm going to begin by rewriting the right side. So we have secant of x times sine of 4x minus sine of 2x. And what I'm going to do is this difference in the parentheses, I'm going to apply the difference to product formula. Okay, so it's a difference of signs. So what I'm going to do is I'm going to use that sine x minus sine y formula that we did on the first page. So this is going to turn into secant of x times, and then our formula is 2 times cosine of the sum of the two angles divided by 2 times the sine of the difference of the two angles divided by 2. All right, and now all we need to do is just simplify the insides of the parentheses. So we have secant of x times 2 times cosine of 6x over 2 times sine of 2x over 2. And I can still divide by 2 inside of each of those cosine and sine. So we have secant of x times 2 times cosine of 3x times sine of x. Okay, so let's stop here and talk about why this is good. So I notice that I'm really close to the left side of the identity. Okay, I've got a 2 sitting around, I've got a trig function that has an angle of just x, and I also have a trig function with an angle of 3x. So now I need to figure out how I can make secant of x and sine of x combine to give me tangent. And it might seem a little complicated, but I think it's a little easier than you think. So secant, remember, we can write as 1 over cosine. So let's see if that helps us at all. So we'll rewrite it as 1 over cosine of x. And then I can really drop these parentheses because everything's being multiplied. So really what we're doing here is we have 1 over cosine of x times 2 times cosine of 3x times sine of x. And so now I have a sine of x in the numerator and a cosine of x in the denominator. So I can actually multiply those together and get the following. So I have 2 times sine of x over cosine of x times cosine of 3x. And looky there. Now I see that I have tangent sitting right in front of me. So that sine x over cosine x is just going to turn into tangent of x, and then we'll rewrite the cosine of 3x, and that's precisely the left side of our identity. Okay, so once again, maybe we got to a place in the identity where you might get a little bit stuck. Okay, the important thing is to think about where you want to go. So we wanted a tangent to appear, and we saw that we had a secant at our disposal, and so we used that to our advantage. Okay, so again, very important. Anytime you get stuck in the middle of one of these proofs, always think about where you want to go and try to map out a plan to get there. So we'll try one more, and this one uses sort of a complicated fraction. That's why I wanted to go through this one. So we have this really complicated fraction on the left. So we have cosine of 2y minus cosine of 4y over sine of 2y plus sine of 4y, and we're saying that this complicated fraction is actually just equal to the tangent of y. So we're going to see that this is true. So here, I'm going to start with the left side, because in this case, the complicated side will be the much easier side to start with. So I'm going to start by rewriting that fraction. So I have cosine of 2y minus cosine of 4y over sine of 2y plus sine of 4y. And now I notice that the numerator of the fraction and the denominator are two separate formulas that are each sums and differences. Okay, so what I can do is I can turn each of the sum and the difference into a product. So for the top, I'm going to use the cosine minus cosine formula, which is -2 times the sine of the sum of the angles over 2. So we have 2y plus 4y over 2 times the sine of the difference of the angles over 2. So we'll have 2y minus 4y over 2. And then the formula on the bottom, we're going to use the sine plus sine formula. So that's going to give me 2 times the sine of the sum of the angles over 2. So we'll have 2y plus 4y over 2 times cosine of 2y minus 4y over 2. Okay, so right away, you may want to just go through the process that we've been doing and just simplify everything in the parentheses. That's perfectly fine. Maybe you also notice that a couple of these things look the same. So if we look at the sine on the top right here, let's see if this is going to highlight for me today. Aha, there we go. And the sine on the bottom right here, they're exactly the same. So they're both a sine function, and the inside is exactly the same. So we have 2y plus 4y divided by 2. That means that we can cancel them because now we have everything multiplied across the top and multiplied across the bottom. Canceling comes into play. So since these are the same, we can just say goodbye. And we can do the same thing with the negative 2 and the positive 2 because they're both 2, but we're going to be left with a negative sign up top. Okay, so I think that's all we can do. So let's rewrite what we have left. So we have negative sine of 2y minus 4y over 2 divided by cosine of 2y minus 4y over 2. Okay, so once again, let's stop and think about why this is a good direction to be heading in. So I know that I want to get to tangent of y, and I know that tangent of y is going to be some fraction of sine divided by cosine, which is what I see in my work. So that's good. So I have sine of some angle, and I have cosine of some angle, and those two fractions that are our angles, they match. So that's good. So let's simplify those and see how much further we can go. So the top, we're going to have negative sine, and then 2y minus 4y is negative 2y over 2, and we'll get the same thing for the angle on the bottom. So we'll have cosine of negative 2y over 2, and I can keep simplifying the inside of those. So we have negative sine of negative y over cosine of negative y. And so now I need to think about what happens to each of sine and cosine when we have negative angles. So sine is odd, so that means we can pull negatives out. So what's going to happen on top is I'm going to have negative sine, which just makes the sign positive. So the top is just going to turn into the sine of y. And then on the bottom, cosine is an even function. So even functions, when we plug negative numbers into them, basically the negatives just disappear. So the bottom is just going to turn into cosine of positive y, which is where we want to go because remember, we wanted our final answer to be tangent of positive y. So notice now we've arrived at the right side of our identity. So that's good. So we've completed our proof. Okay, so that concludes our 7.4 lesson.